Hi, welcome to the Calculus 1 lecture series. And in this video, we're going to take a look at the Chapter 2 practice test. We finally finish our Unit 1, Limits and Derivatives. So this practice test is a good review of the key concepts we learned from our Unit number 1, Units and the Derivatives. All right, let's go ahead and start. We have a lot of problems here, so we better start here. Okay, so the first thing here is like we said, okay, so the graph of f is given, right? Then find the following limits and explain why it's not exist. Okay, so the first one's here. So we always need to be careful about those signs, right? So from the left or from the right, those things, right? Okay, so in here, the first things here is that the limit of f of x, when x approach to 2, you see a plus sign. What's that mean? That means you are going from the right-hand side, right? So when you're going from the right-hand side, then you just follow your graph. So you say, oh, so where I reach to here. So this is 1, 2, 3, right? So you follow your sign. So that's why you get your limit is 3 here, right? Okay, now the next one here is, let's say, I want to find the limit, the -3. So -3 is 1, 2, 3. So it's here. And you also approach from the right-hand side. So this is right-hand limit. Then you just follow your graph. You say, go to the left-hand side. No. So what is going to reach here? It's going to be what? It's going to be 0 here, right? And so like in here, be careful, right? So if I do say that from the -3 from the left-hand side, that means going to approach to -2 here, okay? Be careful. Okay, so now like in here, now let's the number 3, let's say, hey, what is the limit approach to the -3? So I know we need to have both. So that's why I say, okay, let's take a look at what is the limit x approach to the -3 from the negative signs here. So that if you approach to the -3 from the left-hand side, that means this is -3, right? So you go here, right? You approach from this way. So that means you follow the graph, then where they going to? They going to the -2. Because -2 is not equal the limit x approach to -3 from the right-hand side, where is 0. So I know what happens here. This limit do not exist, right? We already, we kind of keep emphasize that idea. When the limit exists, that means right-hand side limit need to equal to left-hand side limit. Okay, let's take a look. X equal to 4. Okay, so when the x approach to 4, okay, so let's take a look here. This is 1, 2, 3, 4. So here, this is where I'm going to. Okay, so now the same things here. I'm taking a look at the x approach to 4 from the right-hand side. Okay, so when the x approach to 4 from the right-hand side, that means you're approaching this way, right? So if you follow the graph, you see from the here, so where you're approaching to, you're approaching to 2, is correct, all right? So the same way you can say, hey, what is the limit x approach to 4 from the left-hand side? Okay, so let's take a look from the left-hand side. That means you approach from here. So you always know you go to the graph to see, okay, I'm going from here to here. So what is this limit going to approach to? Is going to approach to 2. And then I know, hey, the right limit equal to the left limit. That means what is my limit x approach to 4? It will be 2 here, right? Okay, so now let's take a look at this ones here. So limit of x approach to 0. Okay, so let's take a look at the same way, the x approach to 0 from the right-hand side, f of x here. From the right-hand side, that means I'm going to go this way, right? So when the right-hand side and go boom, 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 boom. So what happened here is going to the infinity. So the same way I said limit x approach to 0 from the left-hand side, f of x. That means go this way. So my limit going to what? It's going to the infinities, right? So I know the limit x approach to 0 is still going to the infinity. Or the infinity, you cannot say limit exists. This is still do not exist. Even the x you approach from right-hand side, approach to left-hand side, they both go to infinity. So you can say this is infinity, but still is not exist because infinity is not a numbers, right? Okay, now let's take a look at the other ones here. Let me erase the things we did here. Okay, so the next things here is x approach to 2 from the left-hand side. So this is a 2, right? That means I'm approaching to 2 from the left-hand side. Then you go to your graph. So what happened to here? What is this graph go? This graph go to the negative infinities, correct? Okay, so now the next things here is we find the, when the x the infinity, when the x approach to infinities here. Okay, so when the x approach to the positive infinity, that means the x is go like this way, right? So positive infinity. So what is the graph? Which graph is go when the x go the positive infinity here? It's this graph, right? So you go loose here, right? So what is your graph approach to? Approach to these lines, right? So it's 1, 2, 3, 4. So what is here? So this is 4 here. Right, clear? Okay, now let's take a look at the next ones here. Let's say x approach to the negative infinity. The negative infinity, that means I'm going this way. So here, continue to go this way. So if you continue to go this way, which part is continue go this way? It's this graph, right? So this graph, so gradually, what is this graph going to approach to? This graph going to approach to -1. So here, this is what we called here. This is a horizontal asymptotes, right? So now that's why the part B, let's say, hey, what is the equation of the horizontal asymptote? So we did these two parts. So we know one is approach to this line, one is approach to this line. So how do I write this line? It's y equal to what? Y equal to 4 and the y equal to what? -1 here. And then the next things here we're going to talk about is the vertical asymptote. So the vertical asymptote, that means is something go like this, right? So now let's take a look here. So vertical asymptote, so which one I have here? I have, the in here, right? So I have this one here. This is a vertical asymptote because those graph are close to that. What is the other one? Hey, I have one in here because this leg of the graph getting closer, correct? Okay, so now what is my vertical asymptote? So these lines here, this is x equal to what? This is x equal to 0 and x equal to what? X equal to 2, right? Okay, so then the next things here, they say, hey, what number is discontinuous? Okay, let me erase here so we can have a clear graph to see. Discontinuous here, obviously, so where one is discontinuous, this point is discontinuous, right? Because I have a jump here. Okay, so what is discontinuous here? So we say x equal to -3. So why this one is discontinuous? This is we have a jump discontinuity. Where is the other one we have? This point, right? So this is what? X equal to what? X equal to 0. Why we had the x equal to 0? This one is because at x equal to 0, I have asymptotes, right? So I have vertical asymptotes here. Then I have another discontinuity is here. So x equal to 2. So because I have another vertical asymptote, then we have one other point, is this point, right? So this point is x equal to 4 is also the discontinuity point, because this is the, what we call this is the whole, right? So over this is what we call is, okay, so you can assign the functions, and then so the, then it will be, we call this removable discontinuities here, right? Okay, so we have 4 discontinuous point here. Okay, so now let's take a look at the problem number 2 here. So the number 2 here, we say find the limits here, right? So remember, when we do the find the limits, the first things we always, you need to what? You always substitute your value to your function to see is it defined or not defined. Okay, so if you substitute 3 into your function, so what you get here, so if you substitute 3, so you got a 3 to the square. So it's 9 minus 9 equal to 0. Then the bottom here, this is 9 plus what? 9 plus 6, right? So 9 plus 6 and 9 plus, so it's 9 plus 6 minus 3, right? So you find here, this is x squared minus 9. So this one's here will give you, so this one's here will give you is limit x approach to 3. Then this is x squared minus 9. So this is x squared minus 9. So x squared 3 minus 3 is 0. Then this is x squared plus 2 times x. So it's 9 plus 16. So it's 12, 15, right? So 15 minus 3 is 12. So is this is defined or non-defined? This is defined. So what is this limit here? So this limit is what? Is zeros here, okay? And so, if it's defined, then you don't need to jump immediately. So, oh, let's try to factor those things here. Okay, so now let's take a look here. The next one here is the limit t equal to 2, approach to 2. So what is the top here? So this is 2 to the square minus 4 will give me zeros, right? Then the bottom here, this is 2 to the cube minus 8 will give me 0. So we have a 0 over zeros. Okay, so you remember during the lecture, so we said if you run into the 0 over 0 situation, what you need to do, see here? Well, the first try, see here, you say, hey, can I try to factor out my trouble terms, right? So this is t minus t squared minus 4, t cubed minus 8 here, right? Let's try to, okay, so let's try to factor. So in here, so this is a limit t approach to 2. And so here, this is another your algebra things here, right? So let's say, let's kind of review the algebra part. So make sure you know those are the few very important, the factor in formula, like a squared minus b squared. So this will be a minus b times a plus b here, right? Then we also have a cube, right? So if you have a cube, and in here you can say it's a plus minus, okay? And b cube is here. So the formulas here will be a plus b, and then this is a squared minus ab plus b squares here. Okay, so I'm color coding here. So if it's minus, then this one going to be minus. And then here, this will be plus. You see, that means if you have a squared minus b squared, then your factor will be a minus b times a squared plus ab plus b squared. All right, so be careful about the notations here, right? Okay, so now, so these ones I can change to the a is t, b is 2. So I can say it's t minus 2, t plus 2. All right. Okay. Then here I can say this is t minus 2 because it's a minus times t squared plus now become the plus, right? AB, so plus 2t and plus b squared, so plus 4. Okay, so now you say, oh, that's good. I have a t and t minus 2. I can cancel. So what I have here, you have a limit t approach to 2. So this is t plus 2. Then this is t squared plus 2t plus 4. Now let's put the value inside here. So 2, so it's a 4. Correct? Now here this is t squared, so it's a 4 plus 2 times 2 is a 4 plus 4. So it's 4 over 12. So what is 4 over 12? This is 1/3. Okay. Okay, so now let's take a look at the next problem here. The next problem is the limit x approach to 4 from the right hand side, and this is 4 minus v, and the absolute value 4 minus v. Okay, so be careful here, it's not x, so it's v, all right? Okay, so for this ones here, we also going to use some of our, the algebra. So about the absolute value, those are the things we emphasize a lot in the pre-cal, right? So let's see here. So what's that mean? So I know if the function is absolute values, in order to do something, we need to break out this absolute value. So we say absolute value, you always have a two-way to break it, right? So that means it will be equal to itself if what? If x is greater than or equal to 0. So if it's a positive, and it will be the negative x if what? If x is less than 0, right? So this is quite an important algebra concept about the absolute values here. Okay, so now let's take a look at this ones here. This one is v is approach to 4 from the right hand side. What's that mean? That means v is kind of greater than 4, right? Because from the right hand side. If v is a little bit greater than 4, so what is inside this absolute value going to turn to be? It's going to be somehow negative, correct? Because v is greater than 4, see here, because from the right-hand side approach. Okay, so now after that, we can say, okay, this is how do I break it? I say limit for the 4. Top is already out. I don't need to worry about it. So this is a 4 minus what? 4 minus v here. So remember, right? So because here is negative, so if I want to break out the absolute value, I need to put a negative 4 minus v, correct? Okay, so when I put a negative 4 minus v, then here you say limit v approach to 4 plus, and so this is a 4 minus, okay, so in here, I can just, okay, so, right, so it's a negative 4 minus v. So in here you say, oh, 4 minus v, 4 minus v, boom, boom, I can cancel. So after you cancel, then this will be limit v approach to the 4 plus, and what happens here? Negative 1. And then negative 1 is a constant. So my answer is what is negative 1s, right? So this is also it's super important, right? So if you have the absolute value, how to break it? And a lot of students have trouble. So make sure you know how to break the absolute values here. All right, let's take a look at our next set here, all right? So for the next set here, so let's still do the same things here. First things here, x equal to 3, approach to 3. So what is here? This is the square root of the 9 minus 3 is equal to 0. The bottom is 27 minus 27 equal to 0. So you say, oh boy, I have 0 over what? Over zeros, right? So I know the 0 over 0 is undefined, right? So it's indeterminate. It's not undefined, it's indeterminate. So how do we do that? So one of the skill we talk about during the lecture, we say, hey, most likely if you see the square roots, what do we want to do? We want to find a conjugate, right? So here, so let's see here. See, we still remember that. So this one's here, this is x cubed minus 3x squared. Of course, okay, so this is 3x squared, and this is x plus 6 minus x, right? So we say let's times the conjugate. Remember what is the conjugate? The conjugate is x plus 6. What here is plus x, right? So the conjugate is kind of like the opposite sign here. So if you have a plus, then you have the conjugate is negative. So you cannot just times something. So I need to times exactly the same things on the bottom. All right, so now I'm going to use my algebra formula again, right? So we said a minus b times a plus b. One more time, what is this? Is a squared minus b squared, right? So as you see, we use this all the times, right? So it's very, very important. Okay, so now let's take a look here. So now here, the bottoms here, you see here, this is x cubed minus 3x squared. You say, hey, I can factor out. So this is x squared. So this is x minus 3. Then nothing happened here. So this is x plus 6 plus x, right? Okay, then the top here, a is the square root of x plus 6. So it's a squared minus b squared. So what I have here is x plus 6 minus x squared, right? Okay, so this is x plus 6 minus x squared. No, of course, don't forget my limit, right? Okay, so now I can do a little bit here. So this is x minus 3. Or, you know, in here, I'm skip one step here. This one you can factor negative out, so make it easier. So, okay, so now what I can do here, I can try to factor and to see I'll be able to cancel some trouble terms, not. So the bottom still nothing changes here, right? So this is x plus 6 plus x. Then the top here, so you put this negative sign. So what is x squared minus x minus 6? You factor. It will be x minus 3 and x plus 2, right? So you can factor that out. Now you see, oh, that's very good, right? So x minus 3, x minus 3, I can cancel out. That's cool. And so finally, so this one will be limit x approach to 3. So this is negative x plus 2. And this is x squared and times x plus 6 plus x here. Now you put the value x equal to 3 in. So what is here? 3. So it's negative 5. So this is 3 to the square times 3 plus 6 is 9. So 9 square root is 3. 3 plus 3 is what? Is 6, right? So that's why I have, so final answer, negative 5, 54, right? 9 times 6 is 54 here. Okay, so don't forget, you can always find the conjugate. Okay, so now the next one here, this one should be pretty easy also. So x approach to the negative infinities, right? So this is 1 minus 2x squared minus x4. This is 5 plus x minus 3x4. Okay, so we talk about this when the x go to the infinities, right? So both of the top and the bottom, they both are the polynomials. So if both are the polynomials, then what I only care about? I only care about the highest term, right? So this is the highest term, and this is the highest term. because the highest term dominate. So now the x force and this is x force. So I know they are at the same power, same degrees. And also, we said it's just the constants in front of them. So it's -1/-3. And also, because this is the even power, so even you go into the infinity, negative infinities, right? So this one go to the positive infinity, this one go to the positive infinities, right? And then that's why I can just say, use the constants in the front. So it's -1, -3. So what is here? So this is 1/3 here. Cool. Okay. And now let's take a look at this one here. So this is the limit. Okay. Okay, so the next one's here. This is the limit x approach to the infinity. And this is 2x minus 6. And this is x squared minus 9. Okay, so we go to the positive infinity. So you take a look at these terms here. This is x to the what? So really, this is x to the first power, correct? And in here, inside square roots is x squared. So this is the dominant power, but also because of x squares, right? So the x square, you have a square roots around it. So it turns out this will be the what? The x's here. So that means these two, they still have what? They still have the same power, right? Same degree. So we say if they are the same degrees here, then what happens here? I will use what? I will use the constants in front of it. So this is what? This is 1/2 here. Okay. All right. So now let's take a look at the last set here. Okay, so the last set, let me put this one. We have a space on the, okay. So this one here is the limit x approach to the infinity. And this is the x squared plus 4x plus 1 and the minus x here. Let's see here. Right, okay, so now let's take a look at how do we do this one here, okay? So for this one here, this is very, a little bit tricky and important. So here, x approach to the infinity. What I have over here, I have this is infinity. X approach to the infinity, what I have here, this will have infinity. So I have is infinity or minus infinity. Is this is equal to 0? No, I don't know, right? So I don't know. I cannot make this conclusion because infinity minus infinity is not, is indefined, right? Indeterminate. So that's why we say, okay, let's try to find a way to get rid of this ambiguity. That means it's in the confusions, infinity minus infinity. I know the infinity plus infinity. Let's know, I know this one is true, right? So infinity plus infinity, this is infinity. That's true. But infinity minus infinity is 0? No, we don't know. It's indeterminate, okay? So the tricks here, just like we talked before, this is a limit x approach to infinity. Like if we see a square root, probably let's try to find a conjugate to see the conjugate will help or not. Okay, so this is a minus, so times, this is the x squared plus 4x plus 1 plus x. So this is x squared plus 4x plus 1 plus x here. All right, so this is a limit x approach to infinity. So the bottoms here is x squared plus 4x plus 1 plus x here, okay? And now let's top here. The top is square minus a square, a minus b times a plus b, so it's a square minus b square, so it's x squared plus 4x plus 1 minus x squared. Okay, so let's simplify a little bit. It's x squared. Okay, so the top right now, this one's going to be limit x approach to infinity. Okay, so this is the x squared plus 4x plus 1 plus x. So this is 4x plus 1. So let's take a look at the dominant terms, right? So dominant term is the highest term. So here, this is 4x, right? So what is the exponents here? The exponents here is the first powers, right? And so here, I have a dominator here. So it's x here. So here, even it's x squared, but you take the square roots, this will become x here, right? So I have so basically in here, my top, the dominator is 4x. Then the bottoms here, I dominate is x plus x is what? It's 2x here, right? So now by using the polynomial rule, we said, okay, because the dominator and then x approach to the infinity. So what is the answer will be the coefficient in front of it. So it's 4/2. So it's what? It's 2. Okay, so this one is very, very kind of the important, and it's kind of like a very tricky layers here. Okay. All right, so let's take a look at the next ones here, right? So the next ones here, let's take a look. This is the limit x approach to infinity, e to the x minus x squared. Okay, so e to the x minus x squared. So now we know the exponents here, you can change to this way. So this is x approach to infinity. Then you can say this is the ex to the e the x squares, correct? Okay, so if you put the x to the infinity, what you have here, you still have infinity over infinities, right? So it's indeterminate. So you say, well, I don't know, right? So now we need to figure out a way to find it. So let's take a look in here. So if without this exponents, if I just say the x approach to the infinity, x to the x squared, right? So if I just say that, so which ones go faster? Well, this is a polynomials, right? So this is a dominator. This is a dominator one. And we also know from the polynomial rule, we know if this is a go faster, then what is the whole thing going to approach to? Going to approach to 0, right? So the same way is in here, because x squared go faster, so the e to the x squared will go even faster than this one. So in here, so because both of them is the base is the e, so I'm only compare, I don't, the x and x squared, so I know this thing is going to be a way faster. So what is the answers here? Will be zeros, right? So this is the one we need to be very, very careful. Like the last few is kind of like a little tricky, so we need to be a little bit careful. Okay, so now let's take a look at the limit x approach to 0 from the right-hand side, the arctangent 1/x here. Okay, so let's take a look. See here. So what is the 1/x when the x approach to 0? If you have a denominator approach to 0, so 1/x, but this is from the 0 to the right-hand side. So this is going to approach to what? Going to approach to the, what here is a positive infinities, right? Okay, so now let's take a look. If you still remember, right? So this is my tangent functions. I know the tangent is something like this, right? So now the arctangent is going to So what is the angle that the things go into the infinity? So where is that? So which angle here? This angles, right? So I know that this answer going to approach to the pi over 2 here because the x approach to the z0 from the right hand side. So that's why it's a positive infinity. So that's why this leg, right? So that's why it's approach to the angle pi over 2 here. This is very, very important, right? Okay, so now let's take a look at our last one, then we will take a break and then we're going to, continue this as our second video. So don't want the one video last too long here. Okay, so this one's here, this is 1 over x minus 1, then plus 1 over x squared minus 3x plus 2. Remember, always put in to see what happens here. So x equal to 1, oh boy, what is here is 1 over 0. Then 1, so this is 1 minus 3 plus 2. So, whoa, this is 0 also. So 1 over 0, so this is an approach to, so this is an approach to the infinity. So this will be the infinity plus infinities, right? And also for these ones here, because this is approach to infinities here, sometime this one will going to be the negatives, right? Okay, so now in here, let's see what do we do here. So the infinity, so this one's here because x approach to 1. For these functions here, x approach to 1, in fact, this one can be approached to the positive or negative infinity, right? Because the x approach to 1, this is what we call is the reciprocal functions, right? If you guys remember, so could be this and it could be this, right? Okay, so we could have an infinity. We know the infinity plus infinity is good, but infinity minus infinity, I'm not sure, right? So it's indeterminate. Okay, so now let's take a look. What can we do here? Well, this one doesn't have any like the square roots, so I cannot use a conjugate. No, let's try to see what we can do. Well, first things let's see is a factoring help. All right, so let's do x minus 1, x minus 2. Okay, all right, so now I said, okay, now let's try to find the common denominator. So the common denominator will be what? Here will be x minus 1, x minus 2. And then the x minus 1 term, what do you need to have here? X minus 2. Then plus, this is the x minus 1, x minus 2. So this is 1s, right? Okay. Okay, so now you can combine these two. And let's see anything good happen. So this is x minus 1, x minus 2. This is x minus 2 plus 1. Oh boy, that's pretty good. So x minus 2 plus 1, what did this term become to? X minus 1. Oh, wow, that's good. X minus 1, I cancel out my trouble terms here. All right, so I cancel out my trouble terms. And now I can say this is the limit x approach to 1. And then this is 1 over x minus 2. So this is 1 over 1 minus 2 is negative 1. So it's negative 1. So the limit here is negative 1 here. Okay, we spend a lot of time on the first two problems because the problem number 2 really is like have like 10, like 8 or 9 problems. So it's a lot, but it's very important. So the problem number 2 covered basically all the skills we learn when we try to find the limits, right? So you could do the factoring, you could do the conjugate, and then you could like do the fraction manipulations, those things. All right, that's it. Let's take a break, and then we're going to have another video to cover the remaining parts here. Okay. And so now, and then talk to you in the next videos here. Okay, bye.